Welcome to the DIY Honda Garage channel. The DTC P16F3 indicates an issue with the starter cut relay 1 control circuit low voltage in the Honda Fit models from 2015 to 2020. This fault suggests a problem in the relay circuit, preventing adequate voltage from reaching the relay or its battery source. The starter cut relay is a crucial component that controls the connection between the ignition switch and the starter motor, ensuring the engine starts only when conditions are met. A low voltage condition in this circuit can lead to an inability to start the engine. When diagnosing this code, it's essential to follow the systematic troubleshooting process to identify the root cause, which may include inspecting wiring, connections, and the relay itself. The starter cut relay 1 is responsible for controlling the current flow from the battery to the starter motor. It is typically located in the underhood fuse relay box, where it operates under the control of the Powertrain Control Module, PCM. The PCM manages the relay based on various inputs, including engine conditions and sensor feedback. A malfunction in the relay can prevent the starter from receiving the necessary voltage, leading to a no-start condition. Additionally, the PCM relies on proper wiring and connectors to relay the commands effectively. If low voltage is present in the circuit, it often indicates issues like shorted wires, open circuits, or even problems within the PCM itself. Several factors can lead to the DTC P16F3, including shorted wires in the starter cut relay circuit, which can occur due to insulation damage or wear over time. An open circuit can also be a cause, often resulting from broken or severed wires, disrupted connections, or corroded terminals that fail to transmit signals. Furthermore, a defective starter cut relay itself may contribute to the DTC if it doesn't make proper connections or if internal faults exist. Each of these potential causes presents unique symptoms and requires careful verification during the diagnostic process. Diagnostic data gathered can help pinpoint whether the wiring, connectors, or the relay needs attention. Drivers may notice several symptoms related to the P163 trouble code. The most apparent sign is an engine that fails to start, which could stem from the lack of current delivered to the starter motor. Intermittent electrical issues might appear, where the vehicle starts sometimes but fails at other times, indicating erratic connectivity. Additionally, the presence of fault codes in the system is a critical symptom, as it signals underlying problems that need diagnosing. Drivers may not always be aware of wiring issues. However, if they observe unusual behavior, like clicking noises from the starter, this might indicate the relay not functioning appropriately. The first step in troubleshooting DTC P16F3 is to start the engine. This allows the technician to check if the engine starts normally or remains inoperative. If the engine starts, it suggests the issue may not be consistent or may not present at that moment, prompting further checks. Conversely, if the engine fails to start, this indicates a potential problem that needs to be addressed. It is essential to document the results accurately, as they will guide the next steps in the diagnostic process. This initial assessment helps in verifying whether the issue is intermittent or constant, profoundly shaping the troubleshooting path ahead. In the second troubleshooting step, the technician should turn the vehicle to the off-lock position before switching it to the on mode. This sequence ensures that the vehicle's systems are reset and ready for DTC clearing. Utilizing the Honda Diagnostic System HDS, the DTC should be cleared at this stage. After clearing, it's important to check for any pending or confirmed DTCs again using the HDS. If DTC P16F3 reappears, it confirms a persistent problem exists. Alternatively, if it does not return, it may indicate an intermittent issue, suggesting further examination of connections and wiring could be necessary. In troubleshooting step 3, the technician will focus on checking for a shorted wire in the starter cut relay 1 control line. Begin by ensuring the vehicle is off, and then remove starter cut relay 1 from the underhood fuse/relay box. After removing the relay, the next step is to jump the SCS line with the HDS. Disconnect the PCM connector A51P. This ensures a safe measurement point. With the relay and the PCM disconnected, the technician will measure the resistance between test points on the PCM and the body ground. The expected measurement is 1.0 megaohm or more. If the resistance is adequate, it confirms the wire is functioning correctly, leading to further options such as PCM updates or replacements if necessary. Step 4 involves determining the possible failure area by testing the voltage in the starter cut relay 1 control circuit. To start, the vehicle should be turned to off and the SCS line jumped with the HDS. Once the components are disconnected, the technician will turn the vehicle to the on mode. The next step is to measure the voltage between PCM connector A and body ground. The expectation here is to find battery voltage present. If battery voltage is confirmed, this might indicate that the PCM may need an update, or a known good PCM should be substituted to narrow down the fault. If the test reveals no voltage, the technician should proceed to inspect further wiring and components related to the starter cut relay circuit. The fifth troubleshooting step focuses on testing for an open wire in the starter cut relay 1 control circuit. Starting with the vehicle in an off-lock mode, the technician will first disconnect starter cut relay 1 from the fuse/relay box. The next phase involves checking for continuity between designated test points. The expected results here should demonstrate that there is a complete circuit allowing for current flow. If continuity is confirmed, this indicates the wire is intact, leading the technician to move forward in the process. Conversely, if continuity fails, it confirms an open circuit requiring repairs, which will typically include inspecting wire insulation, repairing connections, and possibly replacing components to ensure the relay operates properly. In troubleshooting step 6, the technician will check fuse number C26, rated at 7.5 amps, located within the under-dash fuse relay box. This fuse plays a critical role in the overall function of the starter cut relay circuit. If the fuse is found to be intact, the technician can proceed with the next steps in troubleshooting. However, if the fuse is blown, it should be replaced immediately. It is also crucial to investigate the underlying cause for a blown fuse, as recurring failures can indicate shorts within the circuit that need rectifying. Thus, after replacing a blown fuse, the technician should follow up with checks of the fuse circuit for any faults. The final step in troubleshooting DTC P16F3 involves checking the IG1 ST cut relay line. The technician should disconnect the under-dash fuse/relay box connector Q40P before proceeding. For thorough testing, terminals A and B should be connected with a jumper wire while ensuring safe and correct test equipment use. The continuity between specific test points must be checked to confirm the wire's integrity. If continuity is confirmed, then the IG1 ST cut relay wire functions correctly, suggesting the focus shifts to possibly replacing the under-dash fuse relay box if faults are persistent. A failure in this step requires the technician to inspect for breaks or malfunctions within the IG1 line, ensuring a solid connection from the under-dash fuse relay box to the starter cut relay 1. After completing the troubleshooting process for DTC P16F3, it's crucial to conduct a final repair verification. This involves rechecking if the DTC is still present or if it has been successfully cleared. Confirming that no new or old symptoms are manifesting is also essential, including ensuring the vehicle starts reliably without issues. Conducting a test drive adds an extra layer of verification, as real-world driving may expose intermittent issues. If everything checks out, it indicates the repair process was successful and the issue has been resolved. If DTC P16F3 reappears, further investigation into wiring, connectors, or PCM functionality may become necessary. Preventive maintenance plays a vital role in avoiding future occurrences of DTC P16F3. Regular inspections of the wiring related to the starter cut relay circuit help identify wear and tear before they lead to failures. Ensuring the integrity of the starter cut relay and its connections will also contribute to smoother vehicle operation. It is advisable to update the PCM software periodically, as manufacturers release updates that can enhance vehicle performance and reliability. Taking these steps can significantly reduce the risk of encountering similar electrical issues in the future, promoting sustained vehicle performance and reliability. In conclusion, diagnosing and resolving DTC P16F3 requires a systematic approach to troubleshooting. Each step must be carefully executed to identify the source of the issue, whether through checking the engine start condition, validating the relay function, or examining the wiring integrity. Understanding and addressing the potential causes will ensure a more reliable vehicle experience for Honda Fit owners. Emphasizing preventive maintenance can help mitigate future problems related to this DTC code, highlighting the importance of regular checks on wiring, connectors, and relay functionality. Ultimately, by leveraging the information provided, technicians can efficiently resolve DTC P16F3 and maintain optimal vehicle performance. Please like and subscribe to the channel. See you next time.